changed it to daylight savings time and or off from daylight savings time. So that's why the bells were all messed up today. It's because everyone blindly, the bell rang, we all left, and then the teachers looked at the clock and like, wait a minute, that was not when the bell was supposed to ring. So we left long enough. Well, all your classes you've left, 5 to 10 minutes early. So. All right, here we go. So quickly, I'm going to run through this very quickly. I need you guys to pay attention, think this through in your head, make sure that we're on track for what we've learned so far. So the first thing we did in this chapter is we talked about tests for divisibilities. We talked about the divisibility rules for 2, 3, 4, 5, 6, 9, and 10. There are divisibility rules for the number 7, number 8. They're just as complicated as if you were to do long division. So that's why the book chooses, well, actually, they never tell us why. But that's why I believe the book does not show you the divisibility rule for 7 and 8. If you're curious, I can show you the divisibility rule. It's just that you're going to see that it's not very pleasant to do. The divisibility rule for 2, though, is a very pleasant and easy one. So you are divisible by 2 if you are an even number. In other words, if the last digit of the number is a 0, 2, 4, 6, or 8. In other words, it's even. It's as quick and easy as that. All right, you should not ever miss is a number divisible by 2, because all you do is you look at the last digit, you say even or odd. Hey, divisible by 2? Yes. Divisible by 2? Yes. Divisible by 2? Yes. Divisible by 2? No. It's that easy, right? There is nothing here that's challenging for divisibility rule for 2. Maybe the most challenging thing are the hard divisibility rules and remembering them. As always, you can have it on a resource card. The test is, I believe, on Friday. Let me go back to the calendar. The test, I believe, is on Friday. Yeah, test on Friday, okay? So absolutely positively for the hard rules, make sure they're on your resource card. We will do a review on Thursday. Divisibility rule for a 3, some of you will remember it, but many of you won't, which is why it should be on a resource card. The rule for 3 says this: look at all the digits and add them up. In other words, add the digits of the number. And then ask yourself, does that sum, is that divisible by 3? So for instance, the first one, 4 plus 3 is 7, plus 7 is 14. We get a sum of 14, and 14 is not divisible by 3, so 437 is not divisible by 3. 1,453, 1 plus 4 is 5, plus 5 is 10, plus 3 is 13. 13 is not divisible by 3, so the whole number is not. 5,101,112, let's see, 5 plus 1 is 6, 7, 8, 9, 10, plus 2 is 12. 12 is divisible by 3. I don't like this example because the last 2 digits are 12. It kind of gives you the impression. That's not what I did. I added up all the digits, so I need to change that for next year. So yeah, 12 is divisible by 3, so that whole big number, that 5 million number is divisible by 3. 51,750, let's see, 5 plus 1 is 6, plus 7 is 13, plus 5 is 18. 18 is divisible by 3, so yes. We good on divisibility rule for 3, okay? Divisibility rule for 4, I'm going to do this really quick today, because all I'm doing is a review. Divisibility rule for 4, it is equally forgettable if you don't lock it into your memory. Just remember, it can be on a resource card. You look at the last 2 digits. We don't do any adding or subtracting, right? No, none of that. That's for rule for 3. We simply look at the 1s and the 10s place. We look what that number is, and we ask if that number is divisible by 4. So in this case, we look at the 10s and the 1s place. That's 12. We say, is 12 divisible by 4? And the answer is yes. So therefore, 312 is divisible by 4. 10,000 number. We look at the last 2 digits, 45. 45 is not divisible by 4, so therefore that big number, 10,445, is not. Big honking number, 11 million. But we only look at the last 2 digits. 32 is divisible by 4. So that big honking thing, we're done in 3 seconds, maybe even less. 58 might be more troublesome because you got to count by 4s. So 58, 72. I mean, when it's larger than 40, you got to give some thinking to it. Let's see, 40, 44, 48, 52, 56. Yeah, we don't get to 58. Okay, so that one is not divisible. Questions on 4. Okay, the second easiest one, divisibility rule for 5. We simply look at the last digit as a 0 or a 5. Remember, we count by 5s. The last digit is either a 0 or 5. So all we have to do is look at the last digit. Yes or no?
No. Yes. No. Yes.
All right, it's that easy. Okay? There's nothing challenging here. Divisibility rule for 6 is forgettable. It's kind of like the rule for 3, but it has 2 rules to it. If you're divisible by 6, 6 only goes into even numbers. So you ask yourself, are you even? And then you ask yourself, does 3 go into? Because remember, 2 and 3 are the factors of 6. So if you're divisible by 2, well then 6, if you're divisible by 6, then you must be divisible by 2. If you're divisible by 6, then 2 times 3, in other words, 6 must be, those 2 numbers must be factors of it. So you simply just ask yourself, is 2 and 3 factors? Or in other words, if it's even and 3 goes into it, you're good to go. Remember the rule for 3, though, says you got to add up all the digits. 1 plus a bunch of zeros is 1. So even though it's even, passes the first test, 3 doesn't go into 1. So therefore, it is not divisible by 6. Hey, this one's even. 5 plus 5 is 10 plus 2 is 12. 3 goes into 12. So it matches both rules. It's divisible by 2 and it's divisible by 3. Odd number. I love putting a big long honking number like this with lots of big numbers on it to see which one I can get to actually add up all the numbers for me. The number is odd. You don't even need to consider this one. Okay? But the last one is even. We got to add those up. Let's see. 9 plus 6 is 15, and 3 goes into 15, so that one's a guess. Okay, 6 is easily forgotten, right? But with a resource card, you don't have to worry about forgetting or not forgetting. You do need to remember how to do it, though. So maybe put like 2 examples on your page for the divisible rule by 6 if you're struggling with it. Questions? Okay, we're running through these very quickly. For 9, we skip 7 and 8. 9, the rule says, it's kind of like the rule for 3. You add up all the digits, but this time you ask yourself, is it divisible by 9? So it's the same process. 4 plus 3 is 7, plus 7 is 14. 14 is not divisible by 9. 1 plus 9 is 10, plus 5 is 15, plus 3 is 18, and 18 is divisible by 9, so that one's a yes. 5, 6, 7, 8, 9, 10, plus 2 is 12. Remember, this one was divisible by 3, but it's not divisible by 9. So just because it's divisible by 3 doesn't mean it's automatically divisible by 9. The last one, that's an 8, that's a 9. Yeah, that one works. Yes? The date is the 3rd. Okay? All right. 10 is the easiest rule as long as it ends in a 0. All right, so that one's the easiest one. So there's your divisible rule. So yes or no?
Yes. No. Yes. No.
All right, those are the divisibility rules. Carly, Richard, those are going to be on the test. All right. Richard, you've been absent so many times, you don't get the joke.
He called her Carly once for like 3 times, and then we told her that it was Riley, and then now we call her Carly.
There you go. Thank you for that. All right, the second thing that will be on your quiz was technically the third thing that we did in class, which was this, square roots. And did I just share this or no? Sharing is caring. Well, so said some cartoon. All right, is that Care Bears or something?
Very much.
All right. Yes. Yes. All right. Up here. So the second, and it was actually the third class, but it was the second major topic we did were these things called square numbers, square roots. The class went like this. I asked you about patterns. I showed you a list of things, asked you what the pattern, and then I showed you a second pattern. Second pattern is if you take any number, right, and we're going to stick to whole numbers, not decimals. Any whole number, you multiply it by itself. The answer that you get to when you take a whole number and you multiply it by itself, those answers, in other words, this column right here in yellow, this column right here, those we call square numbers. And the question is, well, you can see a pattern here. The question is, why are they called square numbers? And I said that if you represent the answers, 1, 4, 9, and 16, by dots, 1 dot for 1, 4 dots for 4, 9 dots for 9, and 16 dots for 16, that the physical shape that you make when you arrange those dots can be, right, a square. That's why they call them square numbers. A better explanation, and this is what the book does, a better explanation is if you think back to 5th grade, 6th grade, you calculate the area of a square. What's the area of a square? Formula. Length times width, but in a square, all the sides are the same. So if one side is 5, they're all 5. 5 times 5 is 25. So the area of this square is 25. Well, let's make it 4. If the side length is 4, 4 times 4 is 16. That's why 16 is the area of that square. That's also why it's called a square number. Okay? All right, so either explanation is why they call them square numbers. All right, so square numbers, they're also called perfect squares as well, too. I prefer perfect squares rather than square numbers. But that's when you take a number, you multiply it by itself. Hey, 25. Not all numbers are perfect squares. 24. There are not 2 whole numbers. 4 times 4 is 16. 5 times 5 is 25. So you 17, 18, 19, 20, 21, 22, 23, 24. There are 8 numbers in between 16 and 25 that are not perfect squares. Okay? What are they good for? Well, they're good for, well, obviously calculating area, but lots of other things that we'll explore later in the year. I had you in that one box write down the first 16. Technically, this is the first 17, because 0 times 0 is 0. I just left that one off. These are the first 16 perfect squares. In yellow are the perfect squares. This was that box 2 from the class period. I said, these are the ones that you need to have on a resource card or know where they come from or be able to recreate it. And I said, this right here was the answer to the entire homework section. Okay? Now, if we read it from right to left, right, we take 2 and it turns into 4. And later on, we talk about square roots, we go from right to left. Okay, so this will be all the answers to all of the questions that deal with perfect squares or square roots. This box right here. All right. Also recall that we can write multiplication simpler with using these things called exponents. Exponents are a way of showing repeated multiplication. We talked about the base, which is the large number, the physical large number, not value-wise, and 2 being the power of the exponent. And I said it's not 5 times 2, it's 5 written twice with multiplication. Okay, so 25. That's where this perfect square of 25 comes from. So this is an alternate way of writing 5 times 5. And I said, be careful. Danger is that it's not 5 times 2. It's 5 written twice. It's 5 written twice. 5 times 5 is 25. 5 times 2 is 10. Hey, that is very rude. Please stop. 5 times 2 is 10, but that's not what powers and exponents do. It tells you how many times to write the base. Okay? So please don't do that. All right, 4 squared is 16, 5 squared is 25, 9 squared is 81. And notice when there's a 2 involved, we say the word square, right? And as explained earlier, that's why it's called square. It's because it literally makes squares, right? If I draw 81 dots, 9 rows of 9, you get a perfect square formed by those dots. Okay, so Carly, Richard, this is the second thing that will be on the quiz. I will ask you, Richard, what's 3 squared? 3 squared is 3 squared is not 6. 3 squared is, this doesn't mean 3 times 2. This means
3 times 3.
3 written twice. That's 3 times 3, which is not 6. That's 9. Richard, 10 squared is
1,000.
It's not 1,000.
100.
Is 100. Richard, 7 squared is
49.
Okay, now you got it. Carly, 15 squared, you don't have memorized. So you either have this on your resource card or by hand you do, yeah. So it's 225 for those of you who have it memorized. 11 squared though, Carly, you should have memorized as,
120.
what's 11 times 10?
100.
At 11.
Oh, okay.
121. All right,
Close enough.
last one. Not 16,
Not 60, sorry.
64. Now you both of you scared me on your responses there. Hey, Richard, you especially, right? You should be able to do this multiplication.
If I had time,
Not 15 squared because that's a new one for you, but the rest of them were things. Okay, so we talked about the second part of this class, which was the square roots. Square roots come from the inverse of squaring. Now, what does inverse mean? Well, let's stick to addition. If I take a number, let's say 7, and I add 2, well, clearly I get 9. If I want to get back to the 7, we do the inverse of addition. The inverse of addition is,
Subtraction.
so instead of add 2 to this number, I should,
Subtract.
if I subtract 2, I get back to where I started. These two things, we don't want to say cancel, but they negate each other, okay? We have the same thing in squaring. We have an inverse of squaring. Now, you've learned the other 4 inverses, the inverse of addition, subtraction, subtraction, addition, multiplication, division, division, multiplication. We now learn our 5th inverse, and the inverse of squaring turns out to be this thing called square rooting. And what does it mean to square root? Well, it means the inverse of squaring. If you square 5, you get to what number? 5 times 5, or 5 written twice, would be 25. So if you want to get back to the 5, you do the inverse of squaring, which is this thing called square rooting. The question is, most kids are like, well, yeah, I know 5 times 5 is 25, but what if I gave you a number and I didn't tell you what I started with? You know, for instance, I give you 196, and I say, well, what number did I start with? And you're like, well, I don't know. That's what square rooting does. It answers that question, right? So square rooting will answer the question, what number squared is the number that I give you? By the way, 196 is 16, right? All right, so that's what we're going to do, and that's because that square rooting is the inverse of squaring. All right, so square root is, well, it's what number times itself, right? It uses a spunky symbol that is not a division symbol. 2 of you on the quiz wrote that the answer to this one is, by the way, square root of 9 is?
3.
You put the answer right here. Right? Now, granted, I didn't minus points for that because 3 is the answer, but it's not a division symbol, right? It's the square root of 9 is 3. Now the question is, why is it 3? This is a long explanation, but why is the square root of 9 3? Well, remember, square roots ask the question, what number times itself is that number 9? The number underneath this funky symbol is called the radicand, and the symbol is called the radical symbol. I throw this out there this year. Next year is when you have to have it memorized, of course, too, but I like to get an early start on it. Okay, so the square root is the inverse of squaring. So here's what it means. It means when you see this symbol, you ask yourself, what number times itself? What number times itself is 9? What number times itself is 9?
3.
3, right? 3 times 3. Well, 3 times 3 can be written as 3 to the 2nd power, right? 3 written twice. And we said that square root is the inverse of squaring. This symbol and this symbol cancel each other out. It's like that plus 2 minus 2. Well, if you add 2 and subtract 2, what have you really done?
Nothing.
You've done nothing. So square root and squaring, if they're both together, cancel each other out. In other words, you didn't do anything. Okay? So in other words, you're just left with the base here, which is 3. That's why the answer is 3. Now watch and look up here. You see my first finger on the left? You see my second finger on the right? You don't actually do this. This is the explanation of why the answer is 3. You don't actually do from left to right finger, but this is the explanation of why the answer is 3. Is that clear? I mean, I'll still have some kids write this down. Okay, great. You know, good. It's true. But it's like saying, what's 2 plus 3? And you see somebody go, well, that's 2 plus 3. That's 1, 2, 3, 4, 5 equals 5. Okay, this is great. It's true. Nobody actually needs you to do that. You simply need to do 2 plus 3. So even though I'm going to show you this middle part, all I really expect you to do is write the answer to the square root of 9, 3. Square root of 25, ask the question, what number times itself is 25? What number times itself is 25? 5. Well, 5 times 5 can be written as 5 to the 2nd power. And a square root cancels squaring, or squaring cancels square root, any way you want to think about that. So in other words, they would erase each other, and you would just be left with the basis 5. Once again, between my fingers, isn't necessary, it's just the explanation of why the answer is 5. Who have I confused there? Good. Square root of 16 is 8, because 8 times 2 is 16, yes? Square root of 16 is 8, because 8 times 2 is 16, yes?
No.
Why? Because the question says what?
B times B.
What times itself is 16? And even though 8 times 2 is 16, I mean, we're not debating that, but it's not the same thing times itself. So you need a number times itself, that number would be
4.
4. Okay? 4, the square and the square root cancel each other out, you're left with 4. Okay? So on the quiz, Richard, the square root of 100 is?
25.
25 times 25 is not 100.
No. Oh, 10.
It is 10. Once again, I'm going to write this stuff, but on the quiz, I expect you to simply write 10. This is the explanation of why the answer is 10. Carly, the square root of 49 is 7. That's the explanation of why the answer is 7. This is the one that you don't have memorized.
It's 15.
It's 15, though. But you can have this on your resource card, right? I would absolutely recommend for both of you that you write 1 through 16. I need to go 1 times 1, 2 times 2, and those numbers, those square numbers, those are the answers to square roots and squaring. Okay? 15 times 15 is 225. The square root of 25 is 15. Note that kind of thing on your paper. All right. For homework, though, since you guys didn't do your homework, so occasionally they give you a very large number. You don't know. You don't have it memorized. Well, what times itself is 4?
2.
So it's got to have a 2 in it, right? So 20 would be our first guess, and it turns out that's the right answer. Okay? So there's a couple weird ones, and the rest of the kids have already done them for homework. Square root of 1 is?
1.
Yeah, because 1 times 1 is 1. Square root of 121 is?
11.
All right. Questions on squares and square roots? All right. Now we will go over what we had on Friday for homework. All right. The last review is on the fun stuff. Prime and whoops, I didn't share. Yes, we did. This was Friday's class. Was on prime and composite numbers. Prime and composite numbers. All right, prime and composite numbers. All right, really quickly. All right, the new game was, we wrote out all the factors, right? These were the factors of all these numbers. We listed all the factors and we noticed a pattern, is that some of the numbers had 2 factors and some of the numbers had more than 2 factors. We called the numbers that had only 2 factors,
Prime.
and we called the numbers that had more than 2 composite, okay? So that's what that was about, was that some of them had 2 and some of them had more than 2. So it turns out that the ones that had 2 were called prime numbers. Those are numbers where the only 2 numbers that go into the given number are 1 in itself. The only thing that goes into 13 is 1 and 13. The only thing that goes into 11 is 1 and 13. The only thing that goes into 2 is 1 and 2. Notice on their list, we only have 1 even number, 2. 2 is the only even prime number. Any other even number, 2 goes into it, so it'll have more than 2 factors, 22. Well, granted, 11 goes in it, but so does 2, right? So any other even number, 2 is a factor, so by that one definition right there, you get more than 2 factors. Okay? So those are called prime numbers. The opposites are called composite. Those are all the even numbers and a bunch of odd numbers as well, too. 15 is odd, but 3 and 5 plus 1 and 15 go into 15. Okay? So don't just assume that it's just the even numbers. 9, 3, 1, 3, 9 are factors of 9. Okay? So it's a bunch. 0, 1 have no friends, right? They don't meet the definition of prime or composite, right? 2 is the only prime number. 0 and 1 are not prime or composite because 0, every number goes into 0. And 1, the only thing that goes into 1 is 1. So if you're defining something as prime or composite by 2 or more, you only get 1. It's like it's a different number altogether. 2 is the only even prime number. Second game we played is, this was what your homework was I gave you a number and you just put prime or composite. Yes? Prime or composite?
Composite.
Prime. Okay, we already did those. Okay. How am I getting that? Is because I'm thinking about now when the number is small, you can. I will tell you over the weekend, the homework, 3001 is a tough number. I believe that was number 16 or something like that. or maybe it was 9 or something like that. 3001 was one of the questions that said prime or composite. I don't know. That's a hard one, right? I won't give you anything challenging like that. It turns out that one was prime. Okay. The second game we played after prime composite was this. Is that we said that, we said that it's called the fundamental theorem of arithmetic, and it said that all numbers bigger than 2 can be written as prime numbers multiplied together, which is crazy, right? We did lots of examples. And I just want to point out, it says all numbers bigger than 2 can be written as prime numbers, doesn't say anything about composite, just prime numbers multiplied together. So the examples that we gave were, let me get to them, was this. I gave you a number, and we did this thing called prime factorization. Prime factorization is, they call it a factor tree. It looks more like roots to me, but it's called a factor tree, and that's where we draw this little shape right here, and the two numbers we put underneath 18 are numbers that are multiplied together that equal 18. And there's lots of choices here. We could have put 1 and 18, we could put 2 and 9, we could put 6 and 3. You're never going to choose 1 and 18, one in itself, because you get nowhere with it. You'll choose any other combination. So for instance, 2 and 9. You will circle any prime number. Carly, is 2 prime? So we circle it. 9 is not prime. Give me 2 numbers multiplied that are 9. So we break that down into 2 more numbers. Turns out 3 are prime. We circle all the prime numbers. Your last step, once there's no more composite numbers to factor, is that we write everything that we circled in red. For 7th grade, we're going to write this as 2 times 3 times 3. For 8th grade, we're going to write it as 2 times 3 to the 2nd power. So I'm just kind of getting you ready for that. Either answer is correct. If you check the back of the book, they will write it like this. All right. I just want to point out this works for any number that's bigger than 2. 24 can be written as 6 and 4, 3 times 8, 12 and 2. Any of those work. I'm lazy. I always, if it's an even number, pick 2. Yes?
Wait, so you said this would work for any number
Above 2. Yeah, sure will. 3 is prime, though, so it's easy. 1 times 3, so just 3. All right, because remember, it said that it can be written as that. All right, 2 times 12, because I'm lazy. 12 can be written as
6 times 6.
6 times 6, no.
6 times 2.
6 times 2 or 2 times 6. We circle 2 because it's prime. And 6 can be written as 2 and 3. And 2 and 3 are both prime. So we can write this as 2 times 2 times 2 times 3, or 2 to the 3rd power times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. Okay. Large numbers as well. I mean, they gave you some rather large ones for homework as well, too. All right, any questions? That's the review. All right, let's grade the homework. Let's grade the homework. Homework was...
That is nowhere close.
Oh, no, that's right. I think we should go.
Yeah.
No, we should go.
No one's going. All right, back up here. So 162, 1 through 30 all. Sorry. All right. I'm going to call these out quickly. Oh, remember, it's a 5-day weekend, so this counts as double those of you who do not have their homework. All right. All right. Hush, please, so I can call out the answers. All right. Number 1 is composite. Number 2 is prime. Number 3 is composite. Number 4 is composite. At this point, you're probably tired of writing prime or composite, and you put C or P, and that's fine. 5 is composite. 6 is composite. 7 is prime. 8 is composite. 9 is composite. 10 is composite. 11 is composite. 12 is prime. 12 was the weird one. 3001, that's cruel to give you a number like that. All right. 13 is 2 times 2 times 3. Did anybody write an exponential form? All right, 2 squared times 3. I'll give you both answers. 14 is 2 times 5 times 5, or 2 times 5 squared. 15 is 2 times 2 times 2 times 3, or 2 to the third times 3. 16 is 2 times 2 times 7, or 2 squared times 7. 17 is 3 times 13. 18 is 2 times 2 times 2 times 7, or 2 to the third times 7. 19 is 2 times 3 times 11. 20 is 3 times 17. 21 is 2 times 3 times 3 times 3, or 2 times 3 to the third. 22 is 3 times 3 times 7, or 3 squared times 7. 23 is 2 times 2 times 3 times 7, or 2 squared times 3 times 7. 24 is 2 times 3 times 3 times 5, or 2 times 3 squared times 5. 25 is 2 times 2 times 7 times 7, or 2 squared times 7 squared. 26 is 2 times 2 times 2 times 3 times 3 times 5. I'm tired now. 2 to the third times 3 squared times 5. 27 is 2 times 2 times 7 times 11, or 2 squared times 7 times 11. 28 is 3 times 3 times 7 times 11, or 3 squared times 7 times 11. 29 is 2 times 3 times 19. The last one is 2 times 5 times 5 times 23, or 2 times 5 squared times 23. And that's it. That's right. Here we go. C, P, C, C, C. Questions? All right. I'm going to give you a worksheet. The worksheet can be done very quickly. We got about 20 minutes left in class. You can all get this done. I had no idea when the bells were ringing. That sounded like Friday's bell or something like that. But,
Probably is.
all right. Could be. All right. Caitlin's coming around. You know she didn't do her homework. Right. Collect your homework.
You see, I have
All right. Nelius is coming around to pass those out, and I am going to be walking around watching you do the homework. So if you need any assistance, for those of you that are absent, homework is still on the board. You can copy it down of what you missed. If you have late work, turn it in as well too. That will work as well. Okay. Questions on what we're doing? What we are not doing, Laura, though, is what? Getting up out of your seat, not doing your work, talking, that sort of thing. Okay? Questions? All right, go ahead and get started. Eleanor, do you have any questions?
I don't have any questions.
I believe you can see the worksheet right now, yes?
Like in Teams?
Yes.
I think it's in there.
Okay. If not, I'll check, and if not, then I'll make sure it's posted by 11:30. But I think I made it posted already. I'm pretty sure I did. But if not, I'll have it up live by 11:30, okay?
Okay.
All right. Catch you later, Eleanor.
Okay, bye.
Bye. Oh, nice background.